we know how to calculate regression coefficients or how to use econometric analysis in Excel environment, isn't it? When we are doing regression analysis, especially, we deal with dependent variable and independent variable. And today we are going to orient with a new software, and the new software is SPSS. We have two software. One is SPSS and another is Stata. Stata. So better we will begin with SPSS because the name of the software is given there in your syllabus. So SPSS is very popular all over the world, and it is a IBM product, American product, and in our country this SPSS is very common. And the precondition is that this is our database today. This is the database, and we will ultimately focus on this database. And this database is known as the cross-sectional data. Cross-sectional data means that there are several characteristics of data. Data. If we want to know today's variable, this includes number one is independent variable, today's data characteristics. And dependent and independent variable is clear. Here in our today's lecture, we'll use salary, CEO salary. This is the salary of the chief executive officers in a year, especially in 1990. See, what are the questions, research question here will be, what are the factors affecting CEO salary? So here we have taken observations from there. We have taken around 209 observations. That means we have taken the records of 209 CEOs, their salary, their change in salary in previous compared to previous year. That means 1990 salary and change in 89 to 90, and the company's self, the company's return on equity, changes in return on equity, company's return on stock, that means dividend. If the company is a firm, is a industrial firm, manufacturing company, if it is a financial company, if it is a consumer product, especially we say FMCG, fast moving consumer goods, consumer product firm, or whether it is a transport or utility firm. So these are the variables. These variables are known as binary variables. Say for an example, if the company works in a industrial firm, then one. So he cannot work in other type of firm. Say for example, financial firm. He cannot work in consumer product firm because these are mutually exclusive. One is he's working in this company. This CEO is not working in this companies. The second CEO is also in industrial firm. The this CEO is working in here financial companies. This CEO is working in financial firm. This CEO is working in financial firms. This CEO, all the CEO, these records are taken from the financial companies. These take records are taken from the financial companies, so he cannot work in industrial company, consumer product company, or transport company. These records are taken. These CEOs who are working in transport company. He cannot work in a consumer product company, financial company, or industrial company. And these records are taken from the CEOs who are working in consumer product companies. Here they are not working in other companies. So these variables in regression analysis, econometric analysis is known as binary variable. This is new variable to you, binary variable. So as a part of business analytics, today we are dealing with cross-sectional data. What is cross-sectional data? Data on different characteristics, variables on a single year. This is the data of different observations. Different observations means here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. These are the observations. 1, 2, 3, 4, 5, 6. That means many CEOs. But dimensions, their salary, their the company's sales, the company's return on equity, the company's return on stocks, etc. These are the many dimensions, but only for 1 year. When you are collecting data for 1 year, one point of time with different dimensions, this is known as the cross-sectional data. So today we are orienting with cross-sectional data, and the data you have used in your project was time series data. The change is you have recorded from 1960 to 2023. So it was a time series. That is a time series data, and this is cross-sectional data. Cross-sectional data, and when there will have more than one variables with time series over time, it will be panel data. So you know that the dependent variable means the variable which depends or affects by the other variables. Here, our dependent variable is salary. What is our dependent variable? Salary is our dependent variable, and these are all independent variables. And among the independent variables, these are, mutually exclusive. Any one of them is true, others are false, mutually exclusive. And this is known as the binary variable. This is dependent variables. So variables dependent, then independent, then binary. Binary variables. These are the binary variables. Binary variables, which is binary, from the computer system, yes or no, 0 or 1. In computer calculations, 0, 1, binary calculations. And here we convert the salary into log salary. We convert the company's sales into log sales. Why we convert these figures into log salaries? Because if you can check the data features, you will find that these figures are very big. 1095 compared to 1 or 191 or 106 is very big figure. And this is also, sales is also very big figure compared to other variables. That's why we convert these values into log. New system of dealing with regressions, that we can convert the data into log values. The system is very simple. What you will do, you will just say LOG, natural logarithm, log salary. This is log salary. So 3 log salary, natural logarithm. But why it is not? Maybe here there is some conversion error. This is just a simple log salary. L salary means log salary, and this is means natural log salary, a natural log of sales. So we use the salary, log salary, and log sales to make the figures comparative. And another feature is that usually with normal variables we can try regression analysis. If the regression result is absurd, then you can use the log figures. Why it shows absurd? Sometimes the data is not linear. You have to convert the data into linear options. To make the non-linear data into linear, we usually use log. We usually use log. So these are the features of today's data. Now we will apply in our business environment or business analytics. Let's go to business analytics software, and we here will use SPSS. SPSS is a statistical software, and this software is very popular for econometric and other business analytics. Here we are using today SPSS for business analysis. Data view. What we are doing here, we are just open. When you will open the SPSS, this window will be displayed. And here in this window, you will copy and paste the data. So we will copy data from the Excel book. The data begins from here to there. So we will not copy the name of the variables. What we will not do, we will not copy the name of the variables, because SPSS automatically take the names as variable 1, variable 2, variable 3, variable 4. So we will only copy the data set and simply paste. Just we are orienting with SPSS to paste. All right. So these are the variables: variable 1, variable 2, variable 3, variable 4, etc. Yes, Mr. Shazib.
স্যার আপনি একটু আগে লগারিদম করছিলেন, তো স্যার সেখানে
Uh,
ভ্যালুটা ডিফারেন্ট আসছিল বিকজ স্যার এক্সেলে স্যার ন্যাচারাল লগারিদমের স্যার ফাংশনটা ডিফারেন্ট আর স্যার ইউজুয়াল লগের ফাংশনটা ডিফারেন্ট।
oh yes, I got it.
স্যার সেটা
That's why I
জাস্ট
didn't
এলএন
say it
ইউজ
is wrong.
করলে এলএন ইউজ করলে স্যার।
N log.
জি স্যার, জি স্যার।
Okay. So natural logarithm, we can convert the log values into normal values into log values here also in SPSS. Okay. Just we are orienting with the software, because when you open Excel, a lot more functions you know from the Excel by yourself, because you have good background. You have some IT skills and better than our old generations. So how to get the data in spaces? Have you got it? Just copy and paste. It is compatible with Excel. So now for your analysis, what you have to do, you have to change the name of the variables. Change the name of the variables. How you can change? The name change is very easy here. Just you will change the name here. So what are the name of the variables here? Number one variable is, what's the name?
Observation num.
No. Observation is not the variable. Begins from here. Salary. Name is, observation number is not important and is not variable. It's just serial sequence. SALARY, salary. Salary means CO salary. All right. Factors. Our target research question is, what is the factors those affect the CO salary in a country? And then it is percentage change, PC, percentage change in salary. SALARY. Percentage change in salary. Variable 3 is sales. Variable 4 is
The return on
variable 4 is
equity.
return on equity. This is also known as coding in research methodology. So there is a chapter on coding. So are you getting what is coding? You are giving a code to the variables.
Variables.
This is known as coding. Very simple. Return on equity, and then percentage
Percentage of
change
return of
in
equity.
return on equity, and then good respond. Then return on stock, that means dividend. All right. How to calculate return on stock of firms, ROS, and whether the firm is industry. Industry means manufacturing company, and whether
Yes.
industry finance, and then consumer product,
Binary
product.
variables.
Binary variables, these are all binary. You can one CEO can take any one of them, not all. All right. Consumer production, and the next one is utility, and then this is natural logarithm. Yes, you're right. Log salary is SALARY, log salary, and the next one is log sales. Why we use the natural logarithm? Because to make the variables comparative, to make the variables uh, how can I say, simple, linear. So now go to the data view, and the name of the variables have changed. Are you getting my point?
Yes, sir.
Variable. Now the analysis we have done in our Excel, we will do here in SPSS mode. All right. So regression analysis. So this is very good system that we can view the window, analyze. You can analyze the descriptive statistics. That means the common descriptive statistics includes average or mean, standard deviation. So you can do this, but here we will do regression analysis. And the regression that we are going to do is linear regression analysis. Linear regression analysis. So use linear relationship. And what is our dependent variable? You can choose here. What is the dependent variable? Dependent variable is
Salary, sir.
CEO salary. All right, salary. And what are the independent variables? Percent change in salary is not important. Sales is one of them. Return on equity is one of them. Return on stock is one of them. Industry, finance, production, utility also factors. These factors also affect the CEO salary. All right. And when you are using sales and salary, you cannot use log sales and log salary. You cannot use log sales because log sales is alternative to sales. Log salary is alternative to salary. Yes, Mr. Shuzib. Shuzib, any issue?
সরি স্যার স্যার এখানে তো স্যার ইন্ডাস্ট্রি, ফাইন্যান্স আর স্যার কনজিউমার প্রোডাক্ট স্যার বাইনারি ছিল। তো আমি
Binary, yes.
স্যার আমি যদি ইন্ডাস্ট্রির সিইও থাকতো তাহলে স্যার ফাইন্যান্স অ্যান্ড হচ্ছে কনজিউমার বা ইউটিলিটির সিইও হইতে পারতো না। স্যার হাউ দিজ আর ইন্ডিপেন্ডেন্ট ভ্যারিয়েবলস ইন টার্মস অফ দ্য স্যালারি?
So we are doing some inferential analysis. We are not doing any individual analysis. We are analyzing the national picture. So these variables will also say if the CEO is working in a finance company, what is the finance coefficient on CEO salary? If it is zero, then it will not give you the coefficient. If he is working in a manufacturing industry, then what is the coefficient that affects the CEO's salary? Are you getting?
Yes, sir, understood. Thank you, sir.
So in your case, the case you have raised is important. It is only for one CEO, but we are commenting on the total inference on the national picture. All right.
Yes, sir, understood.
So now you will add the dependent variables, and after adding the dependent variables, dependent and independent variables, you can just paste okay, you will get the results. This is the results. And especially if you compare with our Excel result, these are the summary of coefficients. All right, the constant is 995. 995. Sales is the sales affects 1%. Return on equity affects 7.9%. Return on stock affects negatively. Finance, if he is working in a finance company, his salary is 272 times more. If he is working in a consumer production company, then it is more than finance company. But if he is working in a utility company, his ultimately salary is much lower than other CEOs. So these are the coefficients, and these are the standard errors. The errors are huge here. 257 is error. Sales coefficient has very poor error. And if we check the R, say for example, R square is 0.285. Oh, R square is 0.081. R square is also very poor. And see the result is something not good, showing absurd results. So as when we will find that this result is little bit absurd, and the t value, if you check the t value, you will find that the t value is also very high. T value means what is your expected error percentage. So t value is very high. It should be less than 5%, or if its significance is 1%, then less than 0.001, 1%. But the t value is very high. R is also comparatively, R square is also comparatively very low. That means only 8% data is explained to by this coefficients, only 8% data. That's why in analysis we have to think alternatively. Alternatively, what we can do, we can think of regression with the log values. So we'll not use these values anymore. What happens when we are using log salary to make the relationship linear? So log salary is your dependent variable and independent variable, as the salary and sales are the big figures. Salary and sales are the big figures. We are converting these two values into log values. So now what happens? Not sales. We will use log sales, isn't it? Industry, finance, consumer product, utility, and log cell, oh sorry, return on equity. These are the control variables, or independent variable is also known as control variable. So what was the result? So you can check now. Here R square is much better. So there was a linearity problem. You make the data linear now by taking the natural logarithm. R square is better. Now it was 8%, now it is 38%, or 35.7%. And what about the coefficients here? The coefficients, return on equity coefficients is return on stock. Sales, positive correlation. If he is working in a utility company, the salary is less than working in financial company and consumer production company. If the CEO is working in a finance company, his his salary is better than utility companies, but not better than who is working in a FMCG or consumer product company. And comparatively, standard errors are very low. And t values here t values is also high, but level of significance, so yes, here the significance is given in a separate column. Level of significance 0, 1, 9, 0, 4, 0, 5, 0. Here standard error is in from the previous results, the standard error is much lower here. So we can use the natural logarithm of the values. So this is how you are using SPSS to predict the values, and this is compatible with cut and copy paste. You can copy and paste in Word for writing your projects, writing your research paper. All right. So you have to explain.
আমরা কি স্যার সেকেন্ড টাইম স্যার ইন্ডাস্ট্রি কি স্যার ক্যালকুলেট মানে কনসিডারেশনে নেই নাই স্যার?
Yes, this is, industry is missing. You are right. It was missing. We should include industry. We should include industry because the variable is there, and we can include industry. Industry is here. Industry, finance, log sales, utility, consumer product, finance, industry, return on stock, return on equity. Yes, variables are there. Finance, log sales. So maybe the coefficient is not relevant. Industry, finance is here, consumer product is there, utility is there, log sales is there. Excluded variables. This variable is excluded because the predictors in this model, the salary T is 0, significance is 0, partial correlation is 0. That's why the variable is omitted. And in statistics, this is known as the collinearity problem. because of if the variable is very much correlated, collinearity problem in econometrics. When the collinearity problem is there, then usually the variable is excluded from the results. So when you will explain the result, then you will say that the data that is available has collinearity problem. Sometimes the word we use multi-collinearity problem. That's why it has been excluded from the results. So this is very fundamental, use of SPSS. That means I am just teaching that how to calculate the coefficients and how to bring the data, how to change the variables, and you can also save this database. When you will save the database, in future, you do not need to rename the variables. The file will be saved properly, and the save format is SPSS statistics or SAV. So in the same way as like the file, you can save it. So when you are saving it, you can open it later very easily. So this is how you are going to use SPSS. Have you got it? How to use SPSS and how to do regression analysis using SPSS?
Yes, sir.
Yes, sir. The basics we got it.
Basic. So if you, I'm just teaching with the methods, and in future you will do more analysis. So if you can open it, if you can do basic analysis, then advanced analysis is possible for you because you have IT skills, and YouTube video, free video is also available about the SPSS lessons, how to explain different coefficients. We are moving forward. More separate example, multi-collinearity problem, heteroscedasticity problem. These are the problems usually we discuss in SPSS. We will also deal with these problems. And today's data characteristics, for your understanding, we use a binary variable, isn't it? A binary variable is a variable that can only take one of two possible values, yes or no, often represented as 0 or 1, true or false, yes or no, and is a type of categorical variable. Categorical variable means qualitative variable, not quantitative variable. An example may be male or female, yes or no in questions, true, false statement, pass, fail, success, failure. And nickname of binary variable is, dichotomous variable. Another name of binary variable, dichotomous variable, another term for binary variable. Also use the categorical variable. Binary variables are a type of categorical variable. That means quantitative variable. Sorry, qualitative variable, not quantitative. And this is also used as dummy variable because 0 indicates something that you are not a CEO of a manufacturing company. So the dummy variable, this binary variable, is also used in regression analysis as dummy variable. So the variables we use today as binary variable, this is also dummy variable. This is also dummy variable. These are the variables we have used in our data set, and the data characteristics we use to raise cross-sectional data. Data characteristics is cross-sectional data. What is cross-sectional data? Cross-sectional data refers to the observations of many different individuals, many CEOs in today's CEO 1, 2, 3. Observation number 1, 2, 3 means CEO 1, CEO 2, CEO 3. Many different individuals at a given time, and the data was taken for 1990 at a given time. Only 1 year's data for many individuals. Each observation belonging to a different individual. Yes, each observation is belonging his whether he is working in a manufacturing company, in service company, banking company, financial company. These are two different CEOs. A simple example of cross-sectional data is the gross annual income. This is the example. So this is these are the salaries, CEO salaries, and these are the different dimensions. So when there will have different dimensions and data will be for a single period, it is known as the cross-sectional data. This is the type of data that is collected about individuals over a single period of time, over various points in time. Also, we use 89, 90. 89, 90, this means changes. That means changes in 90, you need the data from 89. Otherwise, you cannot calculate the change in 1990. That's why. So, various points in time where no special attention is paid to that element. We are not giving a special attention here. No special attention is paid to the time element. Data can be collected using sampling approaches or from historical data sources. So these are the cross-sectional data because there are a lot of dimensions and only for 1 year, 1990, point in time, single period of time. And many observations, many individuals, different dimensions. This is known as cross-sectional data. And another is time series data. Time series data is a set that tracks a simple sample over time. Say for example, a stock price for 10 years. Sample over time. In particular, a time series allows one to see what factors influence certain variables from period to time. Whether the stock price is increasing from 1990 to 2024 or not. Time series analysis can be useful to see how a given asset, security, or economic variable changes over time. Forecasting methods using time series are used in both fundamental and technical analysis. Yes, we use forecast. We made forecasts based on time series analysis. This is the time series data. What is the stock price of the company in 2015, 2016, 2017? You are recorded the value of stock over many points in time. This is known as time series data. Especially another feature of time series data is that this intervals should be same. Say for example, 2015, 2020, 2025, 2030. So the interval also should be equal. Interval will also should be equal. This type of data is explicitly organized in time sequence, generally in equally spaced units such as days, weeks, months, quarters, years, etc. or 5 years gap, 10 years gap. Here data are presented for a single individual. That means single company. Individual means here company, a company. In time sequence order with one row of data for each year. Each row consists of the characteristics under study for the year. Mr. Ryan.
Sir, that means, sir, in cross-sectional data, sir, it's many individuals, but sir, one single time.
One time period. Say for an example, a stock price of a company in 2025, 2015. So in cross-sectional data, you are collecting data only for 2015. All right. And only for 2015, and the individuals company will be different. Maybe 50 companies data you have collected in 2015. Are you getting? 50
yes, sir.
companies data only for 2015 is known as cross-sectional data. All right.
Yes, sir.
And the next one is
time series means, sir, just one individual or one company, but sir, many years data.
Many years data. And combination of time series and cross-sectional data is known as panel data or longitudinal data. Combination. Now here, many years, many dimensions, many individuals. Data are summarized. It is known as panel data. It is known as panel data. A panel data set contains observations on a number of units belonging to different clusters over time. That means not point in time, over time for many years. A simple example of panel data is given here. It is different companies, different years, and different dimensions. Stock price, profit of the company, number of employees of the company, male or female, age of the employees. Are you getting? This is
Yes, sir.
here time series is there. This two column is time series data, isn't it? And time series with different features and many individuals altogether is known as panel data, or it is also known as a longitudinal data. Consists of time series data for each cross section individuals, each cross section. All right. Can be people, individuals can be people, cities, companies, plants, etc. And can time be years, months, weeks, etc. So especially
Sir.
we deal with panel data in econometrics or also in business analytics. Yes.
Sir, is it the most complex data? Because I can see it includes all the other three data.
Features. Yes. All the features of all the data is here. Yes, this is it is complex, but for making better informed decision, you need data, time series data, many features data, many individuals together to make the inference. So this data is the most popular data for making inference about the economy, making inference about the business environment. So although it is complex, but this is very good data for making better decisions. All right. We have already given the example factors affecting fuel salary in SPSS. We started with SPSS applications, and maybe in another lecture we'll show you how to use data. The almost same system. So some commons works there. All right. Stata, we will discuss Stata in another lecture. So do you have any confusions, questions about the use of SPSS in simple regression analysis or econometric model? Do you have any confusion? If you
স্যার
do not have any,
এক্সেলের যে
yes, please.
ডেটাগুলা ছিল, এক্সেলের ডেটাগুলা স্যার কিভাবে রিট্রিভ করা হয়েছে এটা একটু যদি নেক্সট ক্লাসে বলে দিতেন খুবই ভালো।
Do you mean how have I collected the data?
Yes, sir, the Excel was.
Do you mean this data?
Yes, sir.
So to do your research, what you have to do, you have to collect you have to go to a company. And one more important thing is that in your analysis, you should not write the name of the companies, because the company may be in problem for writing the name of the company. So one company, you have interviewed the CEO of the company. This data is taken from the company, one company. All right. Are you getting? So there is no data retrieval system. You have to, as a researcher, you have to collect the data. You have to collect the data. Data may be collected from primary
The
sources
CEO.
or maybe from the secondary sources. The research you have done, you have used the secondary sources, but this data is primary data. And this data is not collected by me. This data is collected from the, from a book. that means it is, you can read the book also. The book is Econometrics, Fundamentals of Econometrics by Woodridge. The maybe the book is not here. It is in my another. Oh yes, we have this database. So you can read the book and the explanation. The book explains that this data in the whole system. Oh no, I need to log in. There is a problem. Sorry, Woodridge. The name of the writer is Fundamentals of Econometrics. The book is Fundamentals of Econo. Is Conometrics. Econometrics writer is Woodridge. 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 Writer is Woodridge. So this data is available there. It is not collected by me, and the data, if you read the book, you will search CEO cell. It is the technical name they have used in their book, CEO cell, and explain different dimensions in different way. And practically, you have got the idea here. Yes, please, Mr. Ryan.
Sir, when we are using any binary variable in SPSS, do we have to mention or make any system for the usage of it, or the SPSS software will automatically read or generate it?
0 1 indicates binary. When you will make the codes, you will use 0 1. All right.
Yes, sir. Then sir, the
Automatically, yes,
SPSS.
SPSS data automatically will detect that this is mutually exclusive, because somewhere there will be 0, somewhere there will be 1. So the SPSS automatically will detect that this is binary variable, mutually exclusive. Mutually exclusive means that you can take one while you cannot take the others. All right. You are a student, you cannot be the teacher. You are either teacher or student. So this is the features of mutually exclusive cases. When we are here in the classroom, I am teacher and I cannot be the student in the same class. This is the binary variable. And we are analyzing the effects of binary variable on the company's CEO salary. And then you will explain, you will write a paper or research report, and you know how you will write the research report. You will use what? Common methods. Say, for example, first you have to write the introduction, then you have to write the literature review, then you have to write the methodology, then you have to write the results, then you have to analyze the results or results discussion, and finally you will write the conclusion. Conclusion will discuss about the summary or answer to the research questions or summary of the research objectives, and then some recommendations and future scopes of research, or the problem that you have faced. You have to give the guidelines how the problem can be overcome. So this is all today, because I have another consecutive class. I have to join there.
I'm from section B, sir.
So just join in section B and then leave. All right. There you will give your attendance.
Assalamualaikum,
Okay.
sir.
Okay, sir.
Yes, Mr. Shakil.
স্যার আজকে অ্যাবসেন্ট দেখাচ্ছে স্যার, আমি প্রেজেন্ট দিলাম তো স্যার 47 বলছি স্যার আপনাকে।
প্রেজেন্ট দিলে আবার অ্যাবসেন্ট কিভাবে দেখাবে? 47 when you say you were present.
স্যার ক্লাস যখন স্টার্ট হয়েছে আমার বাসায় ইলেকট্রিসিটি ছিল না, সো আমি একটু লেট করে জয়েন করেছি। বাট স্যার আমি হোল
So
ক্লাসে
late means বাংলাদেশে ইলেকট্রিসিটি তো এখন আর যায় না। These are the lame excuses, all right?
স্যার আমার বাসায় প্রত্যেক দিনই যায়।
Where is your home?
স্যার শ্যামলীতে।
Where?
শ্যামলী।
But I have to start the another class.
স্যার আসসালামু আলাইকুম। আমি
So
আমার রোল 63 স্যার। স্যার
Possible
আমি ওর 2 মিনিট লেট
23,
63 স্যার।
63, not 23. Oh, sorry.
23 আছি স্যার
Yes.
আমি।
Oh, you are here. And Mr. Shakil.
Yes, sir. 47.
And who is Miss
স্যার আমি 125।
125? So this type of actions we need to minimize. Okay, thank you for joining the lecture, and you will get the records of our lecture. All right?
Thank you,
স্যার
Yes.
স্যার 17 তারিখে স্যার আমার অ্যাবসেন্ট দেখাচ্ছে স্যার। আপনাকে ওই দিন বলেছিলাম স্যার, আপনি বলেছেন নেক্সট ক্লাসে বলতে, স্যার নেক্সট ক্লাসে আর বলা হয়েছিল না।
So it is your fault. We cannot continue anymore. Thank you very much for today.